thinking about trees and considering them like similar metabolism that we have as humans. When we are younger, we are burning more calories. We have a higher metabolism. When we get older and older, we are actually like burning less calories. Our metabolism is going down. So a tree is similar to that concept too. A tree, when it starts growing before being over mature, is actually absorbing tons of carbon dioxide from the atmosphere, from the environment. But then when it goes to a point that it's very close to being over mature and dying, starts decomposing and actually is going to release whatever that it has absorbed to the environment. And that's a carbon cycle of nature. It's a natural process. So harvesting timber or harvesting the trees that they are intended to be timber sustainably can actually benefit the whole carbon sequestration process.
Before we go into the podcast, if you could just go and rate this show on whichever platform you're listening to it, it makes a huge difference to the podcast, the amazing conversations we get to have, and the incredible guests we're able to get on the podcast. So it's probably not something you would think about, but if you could just go rate the show, follow it, or share an episode, it does make a huge difference to the show. Thank you so much. In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipf, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. Mass timber is more than just a building material. It's a game changer for construction, and Shay Kurzinski, today's guest, breaks down exactly why. In our conversation, we explored its ability to cut construction waste, reduce timelines, and drastically lower carbon emissions. She also debunked common myths about timber's fire safety and sustainability, explained how diagonal cross-laminated timber can improve performance, and shared insights on sourcing materials responsibly. So if you've ever wondered how sustainable materials can transform the construction industry, or just want a clearer understanding of what makes mass timber so impactful, this episode is for you. Thank you so much, Shay, for joining me. I'm very excited to talk to you today. Let me start with asking about your journey. What's the earliest piece of context or event in your life that kind of planted the seed for your passion for sustainability and timber construction? Was there like a particular moment that became the first domino?
Well, after studying my bachelor's, when I came to US, I wasn't really sure what I'm going to do. So I studied landscape architecture. And I guess that was kind of like a first domino piece for me, because it made me so much familiar with the knowledge of trees, the knowledge of wood, the forestry, because I studied in State University of New York, Environmental College and Forestry, SUNY SF. And I met so many good people there that they are very much more than me advocates for sustainability and environmentalists, and I think that really gave me so much perspective. And then when I saw an opening for a PhD position, or when I talked to my previous advisor and kind of convinced him I'm a good fit for his grant that he had at that time, I didn't have any idea what I'm going to do, but I was super excited to start a new journey. And I knew that I can use my background as an architect and combine it with some knowledge, or gain more knowledge about construction and then sustainability. And I guess all the pieces got to at some point, I was very lucky that everything just got together and made me who I am right now, and which is a very passionate person about sustainable materials in construction.
That's cool. So Shay, you specialize in mass timber, and we're gonna focus the conversation a lot on mass timber. So first of all, for our listeners who are no experts in the field, could you just in a few sentences explain what mass timber is and why it has kind of the potential to revolutionize construction?
Yes, absolutely. So mass timber, everybody, I guess at some point they're familiar with using wood as a lumber, as a studs, as a stick built type of construction, post and beam, 2x4 lumbers. So imagine having all those 2x4 pieces of wood or pieces of wood planks, attach them together and make a massive sandwich panel, which can actually produce or shows a better structural performance or even thermal or other type of performance compared to just using one piece of lumber in different parts of the building. So it's technically, the name has it itself, it's a massive panels of wood that they get together and produce kind of like an engineered wood product. So basically, engineered wood products started decades ago, right? That we had plywood, for example, or we had OSB or other type of products that they are manufactured from wood. But mass timber is somehow a newer type of engineered wood products, just because of using, for example, very small thickness of wood materials, or even, strands of wood, instead of that using an actual wood material that has a thickness that individually could be used as a part of the building. Now we are kind of like gluing them together, nailing them together, or even using dowel to connect them, and then produce a more massive type of product to use in the building. And that's a huge benefit when it comes to our competitors or the conventional, other traditional type of construction materials, that they're not necessarily renewable or sustainable.
And now I'm asking from an architectural perspective, how does mass timber compare to traditional materials like concrete or steel? Like, how does it influence the architectural design process? Are there any unique design opportunities or constraints compared to traditional materials?
Basically, there are very different categories that I can talk about the benefits of mass timber compared to other conventional materials, which mainly they are concrete and steel as competitors to mass timber. What related to the design, when you're talking specifically about design, so I would say a structural design part of the mass timber comes very much beneficial when we are talking about a very lightweight material compared to a very heavy type of self-weight of concrete slabs or steel. So the ratio, the mass timber products in general, they have excellent strength to weight ratio when it comes to the structural properties, meaning that they're approximately 20%, the strength to weight ratio is approximately 20% higher than a steel, on 4 to 1 times that of a non-reinforced concrete without any rebars in it. So that's a very high benefit, because you're using a very light material, but for that weight, the ratio of that weight that you're putting in your structure, you're gaining a lot of strength. You're providing a lot of structural properties, a stiffness, a strength for your core structural part of your building. And then I would say other benefits related to architecture or even construction type of phase of mass timber is that when you're using mass timber, the procurement and pre-con phase of the mass timber project is usually lengthier compared to concrete, using a concrete or a steel type of a structure or building, meaning that the designers, architects, they spend much more time focusing and showing their skills, and they have more saying when it comes to like a building. And then everything is going to be pre-cut, prefabricated, and everything is going to get sent to the shops and fabrication process. And very small tolerances, very small, precise tolerances and precise cuts are going to be done before even the construction even starts. So the role of an architect or the role of a VDC or virtual design construction engineer or designer is very high value when it comes to a mass timber project compared to other type of project I've seen it. And then when it goes to the construction, everything goes like together, such as like a Lego house. Everything is pre-cut, so everything can goes next to each other, sit next to each other as planned. Most of the times, hopefully, as planned. And so the construction phase, the crews that are going to be on site, they're less in terms of the people, and also in terms of the schedule. It goes very much faster than any other type of project with other conventional materials. So I think these are kind of like benefits related to the construction and architecture of the building. But I can talk about the carbon emission, energy consumption, the less of waste after the construction is done, or all that things compared to the conventional, which is more obvious, I guess, to the audience. But these are some kind of like technical construction related type of benefits. Yeah.
We'll go into all those details during the conversation. So something super interesting that you mentioned, and already when we spoke last time, is that timber reduces on-site labor by around 40%. How does that impact the construction timelines and costs and waste?
So the construction cost when it comes to the mass timber is very challenging to compare it to steel or concrete buildings. But the thing is a lot of the upfront costs that we spend compared to the life cycle and operational costs that the building is going to have is very much less valuable, or the secondary that I mentioned, the later that I mentioned, is very much valuable compared to the upfront. So that's one benefit that the clients that they're working or asking about the mass timber buildings compared to the steel or concrete, they should consider that. But and also when it comes to the schedule, when I'm saying that everything is going to be pre-cut, so the procurement and the pre-construction is going to be a higher type of, it's going to take a longer time in the schedule, which usually is being the only cost for that is going to be the cost of people who are working in the office or the overhead that there is being spent on. But compared to the amount of money that they have to spend to have the installation crew on job site is very much less, compared to other type of conventional materials. So schedule-wise is a huge benefit, very much less headache, mostly for the general contractor companies, because if the huge portion of the building, the core structure is going to be mass timber, that building, when the general contractor is on site and the subcontractor for mass timber comes to the site, it's going to just go very fast, and huge portion of the huge portion of construction is usually when there's a steel being erected or the concrete slabs being poured. So imagine that being just done for 4-story, 5-story at the same time and very much quicker. And then, so that's a huge benefit when you look at the schedule. And when I say that, because the next trade can move into the job site and they start their own, work on the job, which is very much beneficial.
So much more planning and less on work side, I guess also less waste.
Yes, less waste compared to other materials. I mean, I can really talk about the being recycled because yes, concrete can be recycled too, or yes, steel can be recycled as well too. But when it comes to the waste, I think it's a very clean job when it's being done because everything is going to be like prefabricated and come to the job site ready to be installed.
And if we talk about recycling, is the goal more to recycle as much as possible or reuse?
That's a very good question. So something that is actually a challenge right now is thinking about the life cycle or the life after mass timber projects or mass timber buildings, because we have mass timber buildings, but none of them has got to a point that we have to actually recycle that. But we have so many precedents of wooden buildings that you see in very old buildings, even in a small residential, for example. It's usually like the whole purpose is trying to keep as much as the wood volume that they can and just add other wood volume next to it. For example, if you have a huge old building that you're renovating, you're trying to keep the actual wooden girders or beams and then maybe reinforce them by adding another girder next to it, another newer wood type of element next to it to kind of reinforce that. So I think when it comes to mass timber too, I think for the future of the mass timber building is more type of keeping the elements as much as we can and maybe reusing or adding reinforcement to that mass timber element when it comes to renovation, when it comes to that point of the building that we need to think about, those elements that have been installed before.
And is timber really more expensive than steel or concrete?
So timber, technically, if you're talking about a single family housing or a smaller square feet, for example, not necessarily. That's why wood is the main type of material for when it comes to even like a low rise or a mid rise type of building. But so for those type of like square feet, yeah, it makes sense to use even a stick built type of building, right? Just post down beam. But when it comes to high rise or more complex projects, yes, the upfront money sometimes is higher than the competitors for a steel, for example, mostly that type of a structure. But as I said, when we're thinking about mass timber, for example, a client or an owner is thinking about using mass timber compared to other materials, usually they have to think about the other benefits, the lifetime benefits of using mass timber compared to a steel or a concrete type of project. For example, a lot of buildings that are mass timber, as I said, when you're prefabricating, you're coordinating, all this MEP type of equipment that you want to install, mechanical, electrical, plumbing, and everything has already cut. For example, as I said, less headache on the job site, and also for better opportunity for maintaining those elements when it comes to, like, for example, other type of materials that if something happens, if some mistake happens, that's it. Never thought about it in the procurement type of phase of the building.
Where in the US can timber be sourced locally?
So that's a good question because US has different tree zones or like plant zones. Not every tree species can be like grown in every part of the country or similar to other like all around the world, right? So we have southern type of forests that in the US that we can produce southern yellow pine mostly as a main type of a species that can be used for CLT or glulam or for mass timber products. Or in the Pacific Northwest, we have timberlands that their main species Douglas fir, which again, that's another species that can be used for mass timber products. Something to mention here is when it comes to the tree species, right now, standards are only allowing us to use softwood type of a species for this mass timber products. So the actually timberlands or the forests that they have hardwood species, they're not being allowed to be harvested for the fabrication of, for example, CLT or glulam or other materials, mass timber materials. So that's another thing that is kind of like a challenge, and that's for the obvious reason of hardwood being very heavier compared to softwood, and it's not very favorable type of a species or tree type to be used for example, providing a massive panel, massive, wooden panel.
And if I build with mass timber, how can I make sure that the materials are sustainably sourced and not kind of contributing to deforestation?
So when it comes to mass timber, there's always this question or this kind of like a myth that if you're talking about sustainability, and that's one of our main reasons to use mass timber for the green building purpose or concept, or for being more sustainable, then why are we cutting the trees? I think the answer is we need to have a sustainable forest management, and the thing is, whatever lumber that, for example, you purchase outside in a local, for example, store, or for example, if in Lowe's or Home Depot or wherever, if you pay, like, if when you're buying it, you can actually see like a stamp on those lumbers that says, for example, FSC or SFI or other type of certification programs that they're saying that, first of all, on that stamp, you can even see the mill number or whatever that, what is the history of that lumber, before like being cut as a, log or production of the lumber. So those certification programs that they have a stamp on the lumber, actually is telling you that it was being harvested from a timberland, not from a forest or a national forest or something that was not intended to be a timber product or a lumber, right? So that's kind of like a answer to like those type of kind of like conversations that it comes from, why are we even cutting the trees for like producing wood? So the thing is like, yes, we have forests that you cannot touch, and there are forests that are timberlands, and they are for actually being harvested. Answering this question, but in another way, is like thinking about trees and considering them like similar metabolism that we have as humans. Like when we are a kid, when we are younger, we are burning more calories, we have a higher metabolism. When we get older and older, we are actually like burning less calories. Our metabolism is going down. So a tree is similar to that concept too. A tree, when it starts growing before being over mature, is actually absorbing tons of carbon dioxide from the atmosphere, from the environment. But then when it goes to a point that it's very close to being over mature and dying, starts decomposing, and actually is going to release whatever that it has absorbed to the environment. And that's a carbon cycle of nature. It's a natural process. So harvesting timber or harvesting the trees that they are intended to be timber sustainably can actually benefit the whole carbon sequestration process. So there's some kind of like myths related to like those type of ideas or questions. Yeah.
So it's like literally like harvesting fruit before it dies. And how old do these trees get?
It really depended on the tree species, because when we're talking, for example, the hardwood species, they're not getting really mature. And that's another reason why we are using actually or harvesting more softwood globally compared to hardwood, because softwoods, they just grow super faster than a hardwood. Maybe after 20 years, they are like mature enough to be harvested. But compared to a hardwood, that a hardwood tree might actually takes hundreds of years to like be mature enough to be harvested. So it takes a longer time to get that tree back if you harvest a hardwood tree, but compared to like a softwood species.
If you're enjoying the show, I have a small favor to ask that would mean the world to me. By rating and sharing the podcast, you're helping us grow and spreading our mission of making sustainability really desirable and cool to a wider audience. Besides of that, imagine impressing your colleagues with the latest insights on sustainable architecture. So make sure you follow the podcast and become the most informed in the room. Thank you so much for your support. Shay, your PhD focused on diagonal cross-laminated timber. Could you break down what that innovation is?
So currently what we have in the industry that can be used as a mass timber product, for example, for floor stops, or as I said, for shear walls, is a cross-laminated timber, which is the layers of, the layers of wood, instead of being glued together parallel to each other, similar to the concept of glue laminated timber. Instead of that, they are being glued one layer adjacent to the other layer perpendicular. So they're going to be like 0, which is a parallel layer, and then another layer adjacent to that is going to be glued in a 90 degrees. And then what we were investigating in that project that ended up being my PhD thesis was, instead of 90 degrees, each layer being perpendicular to the adjacent layer, I guess we were more investigating the ways to improve the stiffness of the material. So we could actually, when we are increasing the stiffness of, for example, cross-laminated timber or a mass timber product, we are actually thinking about getting the same amount of stiffness, but not increasing the thickness of the material, not making it heavier. With the same sort of material, we're just changing the orientation of the layers. So instead of having one layer at 0 and the other layer at 90 degrees or totally perpendicular, we can investigate that the second layer could be at 10 degrees, at 20 degrees, at 40 degrees, up to 90 degrees, and seeing how much of the structural benefit we can actually get by changing this angle or orientation of the second layer or the perpendicular layer.
Did you find the perfect formula, the perfect degree?
So the thing is, we were investigating it as a shear and also the bending type of, two different type of stiffness, two different type of material property. So yes, so when it goes closer to being a glue laminated timber, it shows a higher bending stiffness properties. But we don't want to have a glue laminated timber, right? We want to have we want to provide some sort of property that goes between being a glue lam and between being a cross-laminated timber. So I guess my point was mostly telling the industry how much of a percentage you can get of having, for example, a diagonal laminated timber at a 10 degree, And then in another chapter, I was trying to say, now you can get, for example, 6%, or I don't know, 20% compared to glue laminated timber or compared to CLT. You can get 20% more stiffness, but at the same time, you can get this much of shear too. So depending on where you want to use it, and depending on if it's beneficial to do that, then you can get this much of this, better property, better material property.
How does mass timber in general contribute to reducing the carbon footprint in construction?
First of all, construction industry, or AEC industry, is responsible for nearly 40% of the global carbon emission. So using a low carbon or carbon smart material can actually reduces the total carbon emission of this, industry that we have. Meaning that using wood, for example, a renewable type of material, not only is renewable, but also it's very energy smart in terms of the manufacturing of it compared to, for example, other materials. And also, as I mentioned, wood is absorbing the carbon from the environment whole its time as being part of the tree. So it's already has all these embodied carbon inside it that has been absorbed throughout the lifespan of the tree. And then when it comes to, for example, the energy that I was talking, so the energy that is required to produce, for example, a cubic meter of a mass timber is about like 60% less than what is needed to produce, for example, a concrete, because concrete is very carbon intense in terms of production, just because of the production of the cement or the binder is very energy intensive. When it comes to timber, the harvesting timber and producing the mass timber products is very much less energy intensive. And compared even to a steel, producing a cubic meter of, for example, mass timber is about 80% less than for the steel production. Because for the steel production, you have to use very much energy intensive at the higher temperature, which are mostly being done by burning fossil fuel. So I think in terms of the carbon footprint, we can actually talk about the fabrication and also the nature of the wood itself.
But timber isn't always the best choice depending on the circumstances. Can you walk me through a situation where concrete or even steel might be the more sustainable option?
As I said, we are still thinking about the cost as a newer material, as a material that needs very much a skilled labor, right? Not only on the job site, we are still lacking people to understand how to install a piece of mass timber in a building, but even people that understand properties of wood as a structural engineers or as an architect, or being familiar with modeling, for example, all these pre-construction or prefabricated elements before being sent to the shop, or even when we are thinking about, for example, so as I said, the I talked about the embodied carbon, but one challenge right now, I'm not sure about the Europe, because Europe has a very much longer history with mass timber, but in North America, we are still struggling with having more mass timber production facilities. So yes, the material itself is very much sustainable, renewable, but when it comes to transporting the material, we have a very higher kind of like carbon emission. Right. So that's one of the challenges right now in North America that we are facing, of asking what facility is closer. So, for example, if I'm Northeast, the closest facility I can get is 500 miles away from me. I can get it from Canada easier because Canada, Toronto is closer to Northeast, comparing getting from a local source in Alabama coming from, for example, a smart down, right? So we are still dealing with this challenge that in terms of the transportation carbon, because when it comes to, for example, life cycle, in the life cycle assessment that we can actually go to like A1 to A4, which is the production of the material itself, or the embodied carbon itself for the material. But when it goes to the transportation in a stage of A4, we have a higher embodied carbon compared to other concrete plants or steel plants that we have, or fabrication or fabricators that we have in so many different areas in different part of the country, or even like in other countries, I assume. So yes, thinking about that might actually add some cost, in terms of getting the material on the job site, finding the people that they are appropriate to put on a job, that they understand mass timber. But in terms of steel and concrete, almost all the education in any school is for the engineering and architecture is talking about the steel and concrete, right? So that's one thing. And also the code limitation is another thing that maybe people would actually benefit to use concrete and steel, because when we're talking about mass timber, we're talking about combustible material. So fire is another challenge that a lot of people have their own concerns about it, about using mass timber, which technically or historically wood can actually shows a very good fire resistance just because of the char layer that can take time to appear around the timber, product, and can actually act as a fire resistant type of layer to take time. It takes time to actually fire gets into the core of that timber element to fall, right? But then again, but it's still that we're talking about a combustible material. Everybody knows that wood is going to burn at some point, right? Even with the char that can act as a fire resistant layer. So the codes are still very conservative about letting, the industry to build taller and more high rise, in terms of mass timber. So limitation when it comes to the IBC, International Building Code, for example, the 2021 led the industry to have up to 18 stories under the category. So added three different categories inside the category of type 4, which is the heavy timber, added type 4A, type 4B, type 4C, saying that if you're using mass timber, as long as there are all the elements of mass timber that are encapsulated, meaning that they have non-combustible material all around them, then you can go up to 18 stories. If you're using, for example, partially exposed mass timber elements, then you can go up to 12 stories. And if you're using exposed mass timber elements, if your design is based on that, if you don't need to build higher than, for example, 9 stories, then you're fine. You can actually build up to 9 stories. And for the newest type of IBC, International Building Code, that in 2024, just in February, 10 months ago, actually, it got released. It had some updates related to allowing 100% of mass timber being exposed in the ceilings, compared to like the previous IBC that was just allowing to have, for example, up to 20% of the ceiling being exposed of mass timber elements. So I think code limitation, the upfront cost, the transportation costs when it comes to the logistics, mass timber could not be very attractive to a lot of people. When it comes to maybe fire resistancy, it would be a little bit hard to go all over around to find the ways that they can meet the fire resistancy and the fire rating that is intended for that a specific building. I think this might be the challenges that maybe a steel and concrete would actually be very much more attractive for people to do that.
I love that you talked about the fire resistancy, because I think that misconception is still in the heads of a lot of people, that we cannot build high-rise buildings, or, well, I don't know if you consider them high-rise buildings in the US, if they're like around 18 stories.
Yeah.
Something I was also thinking about is maybe the lifespan. So I had one guest that focused on exhibition pavilions. So these are very temporary constructions. So maybe in terms of reusability, steel is still a bit more easy to implement, right?
My assumption is that a hybrid type of building is very attractive right now for a pavilion, which we can actually see the newer pavilions being actually using this type of construction method, meaning that we can have mass timber elements that they're actually make the pavilion construction very quick. As I said, less waste, and also less amount of time to get that pavilion up and going, which I think is one of the very important things related to the schedule to a very temporary building, that everybody just wanted to get it done and move to the next project. So But then at the same time, sometimes getting the actual shape out of mass timber might be harder. For example, one of the challenges, which there's still buildings little by little right now, it's getting better because they finally, like, the industry figure out how to actually make curve, out of, or different shapes out of CLT panels. It's not, I'm not talking about that, but usually maybe it's easier to do with a steel, for example, or any other type of materials. But I would assume that just because of the beauty of mass timber that can actually be exposed as a public type of a statue, or a public element, mass timber is still very attractive for temporary structures.
So I have one last question for you. I know you're an academic as well, and you take your students to learn about sustainable practices through like clubs and site visits and with like guest lectures. What has been the most impactful or memorable site visit or speaker engagement that you've organized?
One of the very memorable type of things that I remember, and I think it was very good for the students too, is just the guest speakers that I actually brought from a local subcontractor, mass timber subcontractor that we have in the area. And they brought their own products. They brought the fasteners that they're huge screws, and students were fascinated by looking at them and seeing what they're actually talking about when we're talking about massive elements of wood. So I think that was very, very good for them to actually hear it from people that they're doing the actual job in the industry. And also related to sustainability, I am trying, I'm trying my best, but it's sometimes just, you get so busy with other works. But I have this sustainable construction club that we brought a sustainability director of another company in Northeast, and she talked about so many different aspects that not only mass timber, but waste management in the building, decarbonization, or different methods that can apply to the buildings, and how they can actually simply be done. But at least I think talking about, all these aspects that and not necessarily in all the classes are being talked about for the students, even they have this the slightest impact on them. I think it's very important because they are the next generation. As much as that we can to expose them to what sustainability can simply be done in construction is very, very much important. And I think that's my goal. Just make it simple and simplify it. I know that it's not simple. I totally know that. People are doing, the best. But at the same time, I feel like for the students, because tomorrow they're going to get hired somewhere and they're going to be like, oh, what if we use this cement that has 20% less carbon emission instead of using a Portland cement, a typical one, just contribute to that and analyze the price and be smart about the material that they're going to be using in future in the buildings.
Yeah, like make conscious decisions. I love that mission. That's super cool. And I'm really excited to see the impact you have with your work. So if our listeners want to follow your work and see what you're doing, where can they find you?
They can definitely follow me on LinkedIn. My name on LinkedIn is Shay Kurzinski, and or they can actually check out our website, which is under our program website in Roger Williams University Construction Management Program, and the name of that the group that I have is Timber Research Group in Roger Williams. That regularly we post interesting things that we're doing, or if you're hosting an event, or if your research is going to get completed.
That's cool. I'll definitely link those in the description of the episode. Thank you very much, Shay.
Thank you so much.
A huge thank you for listening. make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at LadinaShipf. Thanks.